Let me introduce first. This is C. Siva, and I'm studying third year of Integrated MTech Software Engineering at Vellore Institute of Technology at Chennai. And today we are going to see about a Diffie-Hellman key exchange for two parties and more parties. The purpose of the algorithm is to enable two users to securely exchange a key that can be used for subsequent encryption of messages. The algorithm itself is limited to the exchange of secret values. The Diffie-Hellman algorithm depends for its effectiveness on the difficulty of computing the discrete logarithms. Uh, Let me introduce for two users. There are two publicly known numbers, a prime number q and an integer that is primitive root of that prime number. And suppose the user A and B wish to exchange a key. User A selects a random integer xa which is less than prime number and computes ya that is public key, and similarly user B independently selects a random integer xb which is less than the prime number, and user B will compute the yb which is public key. Each side keeps the x value private and makes the y value as available publicly to the other side. User A computes the key as k, that's a secret key, and user B computes the key secret key. We will go into deep in this. Now you can see these two calculations of the secret key produce identical result, that is k equal to y from user side, from user A side, yb power xa mod q, and alpha power yb equal to alpha power xb mod q whole power xa and mod q. Now alpha power xb whole power xa mod q, that alpha power xb xa mod q and alpha power xa and mod q whole power xb and mod q. Then it becomes, this whole formula is to go for ya, that is ya whole power xp mod q. Now we will see the Diffie-Hellman key exchange for two users. That is, the two parameters are required for Diffie-Hellman for two users, that is q, that is prime number, and alpha, which is a primitive root of prime number. Now here two users are user A and user B. From user A selects private key, that is xa, which is less than the prime numbers, and user B also selects the private key xb, that is which is less than prime number. And user A calculates ya, which is now we will see Diffie-Hellman key exchange for three parties. That is, finite q is a fq is a finite field, and there are three users now, that is user A, user B, and user C, and they are user public key of user A is ya and private key of user A is xa, same as B's public key is yb and private key is xb, and same as C's public key is yc and private key is xc. Every user's public key and private key have the function relation, that is y equal to g power x, that is to say ya equal to g power xa and yb equal to g power xp, then yc equal to g power xc. Here, if A, B, C want to establish session key, they have to perform two rounds, that is round 1 and round 2. A and here B and C. Those are random numbers chosen by the users only. And TAC equal to YC power AXA and sends to TAB, TAC respectively to users B and C. As same as user B randomly chooses constant number B in FQ, calculates and make public key that TBA equal to YA power BXB and TBC equal to YC power BXB and sends TBA, TBC respectively to users A and C. And same as a user C randomly chooses a constant number C in the finite field and calculates TCA equal to YA power CXA, TCB equal to YB power CXC and makes them public and sends TCA, TCB respectively to user A and B. Now we will see round 2. Nothing but user A, we are sending the public keys from one user to other users. Now here we, we are receiving the keys from both the users. That is, user A receives TBA equal to YA power BXB sent by B and TCA equal to YA power CXC sent by C. And then A calculates like this, TBA power XA inverse equal to YB power B, that equal to B power B G power BXB and C TCA power XA power in minus 1 equal to YC power C, that equal to G power CXC K equal to G power AXA and G power BXP dot G power CXC, that nothing but G power AXA plus BXB plus CXC. As same as user B receives TAB equal to YB power AXA sent by A and TCB equal to YB power CXC, that is sent by B, and B will calculate like TAB power XB minus 1 equal to YA power A equal to G power AXA, TCB power XB minus 1 equal to YC power C, nothing but G power CXC. Now that is calculating secret key, that is K equal to G power AXA into G power BXB into G power CXC. Now this is nothing but A power A power 1, A power 2, A power 3. We are adding the exponents like G power AXA plus BXB plus CXC. Now user C receives TAC equal to YC power AXA sent by A and TBC equal to YC power BXP sent by B, and C will calculate TAC power XC minus 1 and YA power A equal to G power AXA. Now TBC power XC minus 1 equal to YB power B equal to G power BXP, and the secret key is K equal to G power AXA dot G power BXP dot G power CXC, nothing but G power AXA plus BXB plus CXC. Now we will see whole in the one part. Now we will see Diffie-Hellman for three parties in whole. Here the protocols is nothing but the steps we are following here, and the users are user A, user B, user C, and we are having two parameters, that is one public key and private key, that is for user A YA XA, for user B YB XB, for user C YC XC, and each user will generate a random key, that is A B C uh, for the protocols. That is in round 1 calculating and sending nothing but TAB, we are calculating TAB equal to YB power AXA to the user B, and TAC equal to YC power AXA to, we are sending this TAC to the user C, as same as for user B calculating TBA equal to YA power BXA and TBC equal to YC power BXP. We are sending TBC to BA to A and TBC to the user C, and user C will calculate TAC equal to YA power CXC and TCB equal to YB power CXC. User C will send the TCA to the user A and TCB to the user B, and user A will receive the TBA and TCA from the user B and user C, where user B calculating the TBA and sending the user to the user A, and user A is receiving TBA same as TCA from the user C, and user B receiving TAB from user A and TCB from user C, as same as user C will receive TAC from user A and TBC from the user B. Now we will move on to the round 2, that is our user A will calculate TBA power XA power minus 1 equal to YB power B, that YB power B nothing but G power BXB, and he will calculate the another element, that is TCA power XA power minus 1 equal to YC power C equal to G power CXC, and he will calculate the secret shared key, that is K equal to G power AXA plus BXB plus CXC. And now move on to the user B, that is TAB power XP power minus 1 equal to YA power A nothing but G power AXA, and TCB power XB minus 1 equal to YC power C equal to G power CXC, and user B will calculate the shared secret key, that is K equal to G power AXA plus BXB plus CXC. Now we will move to the user B. User B will calculate TAC power XC minus 1 equal to YA power A, that equal to G power AXA, and he will calculate TBC power XB power minus 1 equal to YB power B equal to G power BXB, and he will calculate the shared secret key K equal to G power AXA plus BXB plus CXC. Now we will see Diffie-Hellman key exchange for two parties as one example. Let us assume Q, that is prime number equal to 71, and alpha, which is primitive root of 71, that is 7. Now user A will select the private key XA equal to 5, and he will calculate the YA, which is public key, that is alpha power XA and mod Q, that is YA equal to 7 power 5. 7 is nothing but the alpha, which is primitive root of 71, and 5 is nothing but the private key of user A, and mod 71, 71 is the primitive prime number, and he will calculating YA equal to 7 power 5 mod 71 nothing but YA equal to 51, as same as user B will select the private key, that is XB equal to 12, and YB equal to, we are having formula like alpha power XB mod Q. Alpha is the primitive root of prime number, and XB is the private key of the user B, and Q is the prime number. He will calculate YB equal to 7 power 12. 7 is alpha and 12 is XB. I think that private key of user B, and alpha is primitive root of prime number, and mod 71. 71 is prime number. after calculating this, we will get yb equal to 4. Now, user A will send his public key to the user B, and user B will send his public key to the user A to calculate the shared secret key. That is, we having formula for A, that is k equal to yb. Yb is nothing but public key of user B, and xa is nothing but private key of user A and mod q. Then we are calculating k equal to 4, yb equal to 4, and xa equal to 5. Then mod 71. After calculating this step, we will get k equal to 30. And from the user B side, we are calculating k equal to ya power xb mod q. Ya is nothing but user A's public key, and xb is nothing but user B's private key and mod q. We are calculating k equal to 51, ya equal to 51, and xb equal to 12. That is 51 power 12 mod 71. After calculating this step, we will get k equal to 30. Now we can see both k's equal to 30. That means both can share the message, the shared secret key, each one. As of now, we saw Diffie-Hellman key exchange for two parties as an example. The same example will work for Diffie-Hellman key exchange for three third parties or more parties. And with this, today's session is completing. We will meet in the next session. Thank you.